All right, so my name is Brandon Schmitt. I will be presenting today on Lean Space. Let me see what I actually titled the whole thing. Let's see, Lean Space. I shortened it for my slide deck here. Basically, I'm going to talk about some of the research that we've done within our own group on applying effective, efficient, lean software and system development practices taken from best practices from internet and enterprise environments and applying those to spaceflight development, particularly on safety critical missions. I'll give a couple of examples as I go through this of how we've applied these topics to some of the real missions that we're developing. All right. So the basic idea is to reduce the cost, risk, and really manage risk throughout a development program. It starts out with the systems engineering work that's done at the beginning of a project, well, really throughout a project, right? So the risk can be defined or can be managed, we believe, by the development methodologies, the approach that you take to systems engineering. And so we've experimented with a couple of different projects on how we can effectively apply concepts like agile development and iterative development cycles and make those work well, make those compliant with NASA 7150, 7120.5, that are compliant requirements. So, like I mentioned, I'll talk a little bit about some of the work that we've done, and I'll try to show you some of the real-world processes, tools, and best practices that have come out of our research. So, just a very quick little slide about me. I come to this problem coming from an internet and enterprise development world. So, I started out my career in doing web applications and database systems, etc. And then in the last, well, I guess the last 7 years or so, has been aerospace and more embedded development. And so I've taken these ideas, we kind of took these ideas, these things that worked well in those environments, and we're curious as to why are we still doing things the same, proven to be not quite as effective as they could be, ways of approaching development. All right, so why is this important? Well, your development methodology, it encompasses your entire workflow. Everything from the quality, reliability, and maintainability are tied up in this process. Something that a lot of people that I talk to don't immediately realize is that your management of risk is also closely tied to the way that you approach development. So, and by risk I mean a variety, right? There's reliability risk, there's safety risk, there's also integration and test risks associated with the performance of your program. So, so risk can be managed in some ways by the way that you approach development. There are ripple effects to the way that you choose to design a spacecraft or to design a system. And so if you choose, and we'll walk through a couple of development methodologies as I talk in the next couple of slides, but your work environment, the tools that you select, the way that you propose projects, among others, are all affected by the way that you approach design and development within your teams. So this waterfall is probably the most common development approach that I've seen throughout my career. So it's very sequential. You start out with, for those that aren't well, I'm sure everyone in this room is familiar with how the waterfall development approach. It's how we design missions. It's how we design electronics. It's how we design mechanical systems. It's also it's also the most common way of developing software. And so you start out with a requirements definition phase. You go through a preliminary design, a high-level design of your system. There's typically a preliminary design review. You go through a more detailed design, and you have a critical design review. you go through an implementation phase, an integration phase, and a test phase. And the basic idea is that you complete every one of these phases sequentially. You get through all of the design before you move on to your development, all of your development before integration, etc. on the test. In theory, I love the idea of waterfall development. You think through all of the problems, you work out all of the design, you make sure all of your pieces are going to be put together, and then you just build it and test it, right? The real world works that way, right? And so the challenge comes in when the real world diverges from this idealistic view. And so things change, right? Modern day, well, I shouldn't even say this is modern day. It's probably always been this way on the vast majority of projects, but you're always constrained, right? There's never enough time. There's never enough budget. One aspect I could say modern day is, especially for small sat and CubeSat missions, especially for the ones that we've been involved with, a lot of times it seems like your schedule's really being driven more by launch opportunities and when you have an opportunity to get on as a secondary payload. And so that if those opportunities change or new ones arise, it may impact after design. Your mission may change. You may learn more as you go and find different tools, different mission profiles, and things change as you get into development. And so this is where, that's where Waterfall starts to struggle a little bit. All right. So Waterfall, I'll talk a little bit about limitations in a second here, but Waterfall works really well for large teams that need coordination. So you have different groups, you've got a massive program, you need to somehow sync up these multiple design and development efforts. If you have very long development cycles, then Waterfall can work well in that as well. And if you have opportunities to work through those phases. And if you happen to have a project that has very solid upfront definitions and they're not going to change, again, waterfall development, the sequential development can apply. The problem is that real-world projects are dynamic. I came across an interesting study a while back when I was looking at and thinking about how to approach development within my team. I kind of missed this a little bit in the introduction, but my role within my team is the chief software architect for a number of our programs and the software team lead. So I'm constantly looking at how can we be effective in the development of the spacecraft systems, aircraft systems that we design. So this study that's up here on the screen, I'll read it very quickly. A study of 400 waterfall projects have shown that only a small portion of the developed code has actually been deployed or used. The reasons for this are the change of needs and the lack of opportunity to clarify misunderstandings. And granted, this is a little bit of an older study, but I think the basic premise still holds. Waterfall works well if things are static and you're not going to change, or you don't have as many changes. And this study of a fairly sizable number of projects had found that only a small portion of the code that was developed was actually made its way into the final product. All right. So there are other ways, and these are some of the approaches that we've been experimenting with in our team. And one of the projects that we've been experimenting with this on, I'll show some more details with, is the Sunjammer technology demonstration mission of a solar sail. So it's a fairly large project, a sized team. We've got about 14, or depending upon if you count interns, we have 14, 15 people working on Sunjammer. And so we apply these agile, we've been able to apply these agile methods to a real spaceflight mission. So they're popular. They're modern development practices, although I say modern loosely because the Agile Manifesto came out more than 10 years ago, probably 14 years ago. The basic idea is, instead of doing everything up front in a sequential order, you work through small chunks, these little batches. So you develop the software, the systems, the design, instead of doing sequentially all of the design up front, then all of the implementation, all of the integration and test. You do some level of design up front, followed by these iterative cycles where you do critical design, implementation, integration, test. I'll talk a little bit more about that here in a minute. but the basic focus, the focuses are a little bit shifted. It's the same basic things, but you maybe use a little bit different tools. You focus on collaboration. You focus on developing working software quickly while minimizing focus on process. Small modular cycles enable adjustment and adaptivity. And then change. This is the one that I like, and I usually get a little bit of a response or reaction when I talk to a new team about this concept. We encourage changes in development scope. And that's a little odd thing to say, because usually that's a very bad thing, right? When you say that in a team that is used to traditional development methodologies where a change in scope or a change in design means a significant amount of rework, concepts like changing development scope are highly discouraged. Our goal in the processes that I'm going to show you here in a few slides is that the impact of that is significantly lessened. So we can come into a conversation and we can go, changes are okay, all right? And that's again in spaceflight in spaceflight it seems like that is something that is generally discouraged. All right, so here's an example of our workflow. You start out with in a traditional program. We kind of walked through these, so I'm gonna talk through this cycle very quickly. It is the traditional system or software development life cycle. You start out with requirements definition. In the enterprise world, it was product requirements. Oftentimes in spaceflight, we refer to it as mission requirements. So mission requirements, system requirements. We go through a high-level design with preliminary design, detailed design with critical design, implementation, integration, system test, release, then maintenance. And really, it's shown here as a flow, but it's really a cycle, right? So a lot of times, you may have a product that evolves over time. And in spaceflight, you have your product, your spacecraft that launches. Perhaps you do an update to add new features, or the next generation, you use this as a base. The way that we have adapted this. The way that we have adapted this to a lean or an iterative approach to development is we still work through these first design steps. We still have mission requirements, and we still have system requirements. We still go as far as a preliminary design and hold a PDR, but that's where our missions tend to diverge from a traditional waterfall approach, and that's kind of why I call this like a lean space approach. It's a little bit of a combination of the two. It's taking those best practices from internet and enterprise development and this agile and lean and extreme programming and unified process and just these practices that have been devised over the years, and we adapt them now to make them compliant with 7150 and 7120.5. So we go through this initial design, and then we have this iterative phase where critical design, implementation, subsystem. There are a number of studies that have shown that iterative approaches and agile approaches can be more effective. And there's one here on the bottom that I think is particularly, interesting. So when Aerospace America in 2012 put out the study that said that 70% of a typical aerospace program's development costs are in software. So if you can make that aspect of development more effective, then just through the way that you approach development, then you can save your small spacecraft development costs. You can save a significant amount in your small spacecraft development costs. Another study that is applicable and interesting is that NIST put out a study a number of years ago that said that up to a third of the development cost of your program can be reduced simply by finding bugs earlier. And so if you are working through and doing integration earlier, and you're integrating throughout your program through an iterative approach like we have found to be effective, then you're finding those bugs a lot sooner, and you are able to reduce your costs. Okay. All right. It looks like I'm a little bit out of time, so I won't actually be able to get into showing you how we approach the Sunjammer program development, but if any of you have questions, I'd be certainly happy to answer them.